My dear people, this is the Bernoullis equation. I know what you're thinking. You're thinking, oh my goodness, this is so long and it looks so complex and complicated. I have no idea what this is. How am I even going to remember this? Okay. I thought exactly like you. But let me just make it so very simple for you. Okay. Let us look at a very small part of Bernoulli's equation. So, what are the things that we know? The total energy equals the pressure energy plus the kinetic energy plus the potential energy. These are the three different energies that there are, as we saw. What is the pressure energy? Do you all remember from thermodynamics? Pressure energy is PV, pressure times volume, plus kinetic energy is half mv square. But since we are using v for volume, I'm going to use c square, plus potential energy is mgh, but instead of h we are using z in fluid mechanics. Now what I'm going to do is I'm going to divide all these things by volume. So volume on volume gets cancelled. So what do I get? P is the only thing, plus mass by volume is density. Mass by volume is density. Do you remember? So density rho c square divided by 2, plus again mass by volume is density. So rho g z. Look at this. How am I to zoom out now? Ah, there you go. Yeah. See, what have we got? Yeah. P plus rho c square by 2 plus rho gz. And this is, if this is for section 1, then we put 1 1 1. So what does Bernoulli's equation say? It says that the total energy in section 1 equals to the total energy in section 2. So if that is the case, I'm writing the total energy for section 2 exactly the same, but with 2 here, 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 to say this is section 2. This is what Bernoulli's equation is all about. Do you see how very, very simple this is? Huh? But you know what? Rather than writing it in terms of energy, I want to write it in terms of height, because it's going to make it so very simple for us all. If I want everything in height, which is z, what should I do? I should divide this equation by rho g. Yeah. So if I divide p1 by rho g plus rho c1 square by 2 times rho g, yeah, plus rho g z1 by rho g. Yeah. So p by rho g is just p by rho g. Okay. Plus rho gets cancelled. So I get c1 square by 2g, plus again rho and g gets cancelled. Z1 equals, if we do the same thing here, it would be p2 by rho g plus c2 square by 2g plus z2, and all of them, the unit is meter. Do you see how simple the derivation is? So very simple, is it not? Yeah. So Bernoulli says head is written as P by rho g, which is nothing but the pressure head. This is what we call as the pressure head, because we have the pressure term here. Do you see pressure term here? So this is called pressure head. And since we have the velocity here, what do you think this will be called as? Huh? Very good. This is called the velocity head, c square by 2g. And this is just the height or the datum. So what do you think this will be called as? Fantastic, the datum head. Bravo, bravo. Now, if I add all these things together, so do you remember if when it was represented, Bernoullis equation was represented as energy, when I added all the energies, it became total energy. But now, if I add all the head, what do you think it's going to be called as? Excellent, the total head. This is how simple Bernoullis equation is. Yeah. So Bernoulli's equation as head is written in this way. So P1 by rho g plus C1 square by 2g plus Z1 equals P2 by rho g C2 square by 2g plus Z2. Do you all remember I asked you a question about the relation between pressure and velocity? Quite a few of you told me that when the velocity is high, the pressure is high. Huh? Well, actually, it is the opposite. When the velocity is high, the pressure is low, and vice versa. Why? Look at this. If you look at the Bernoulli's equation, let us just consider this alone, the first section alone. Yeah, the gravity is not going to change, the height is going to be the same, and the density of the liquid is not going to change. Okay, so if the velocity increases, in order for the equation to balance out, pressure should decrease, should it not? Yeah. And if the velocity decreases, just to balance the equation, the pressure should increase. This is one of the major applications of Bernoulli's equation, and one of the reasons why we are able to have liftoff in the flights. Yeah, look at this. Here the area is larger, which means that the velocity is going to be lower. Look at the pressure. Pressure is high. Yes. Whereas here the diameter is small, which means that the velocity is high. Look at the pressure. The pressure is low. Do you see, when the velocity is high, pressure is low? When the velocity is low, pressure is high. Yeah. Now you can use this to answer my question about the sheet of paper and also about the yellow line in the train station. Let us go and look at a problem, shall we? Huh? Okay, what do we have here? In this example, we are given that there is a pipe of diameter 5 centimeter which carries water under a pressure of 294.3 kilopascal. I saw an error here. I'm not sure if you have all noticed it. Pascal, it should be capital P, small a. Yeah, I deliberately made this mistake so that you would notice. Well, not really. But at least that is what I want you all to think. Okay, anyway. And the average velocity with which the flow is happening is 2 meters per second. That's what they've given us. So in this particular pipe, we are asked to calculate what would be the pressure head, the kinetic, or the velocity. They're both the same. Yeah. And they have also given us that the total head is 5 meter above the datum. So the datum head is also given. I just want you all to understand something. The total head in some of the books is also mentioned as the total energy per unit weight of the liquid. Yeah, it's quite long, so I just call it as the total head. Is that okay? Yeah. So one of the things I was able to learn thanks to noticing some the lectures by Aruna, whenever there is a problem, you just highlight all the important things that you want. So the diameter is highlighted or just underline it. The pressure, the velocity, the head already came with an underline, didn't it? Yeah. So these are the four important information we know to find the pressure head, kinetic head, and the total head. Shall we get going? Yeah. We are given the diameter to be 5 centimeter. So I'm converting it into standard form, 0.5 meter. We are given the datum head 5 meter, the velocity and the pressure. I've just written them all over here. Yeah. And to find, we need the total head. The total head, as you might all know, is the pressure head plus the kinetic head plus the datum head. Yeah. So what is the pressure head? The pressure head equation is P by rho g, where P is the pressure, rho is the density, and g is the gravity. Kinetic head is c square by 2g, where c is the velocity. Yeah. Datum head is just z. So all that we have to do is just substitute the values that we know in these equations. How simple this is it not? Yeah. It cannot get more simple than this. Okay, the pressure head we know is P by rho g. So we know the pressure value. Rho is the density of water because it carries water. Or if it's not given, you can just take it to be water. 1000 times 9.81. You put it in the calculator and you get the pressure head to be 30 meter. The kinetic head is c square by 2g. All that I do is that I just substitute the value for the kinetic head. So c square is 2 square divided by 2 times 9.81, which is the kinetic head. What about the total head then? Total head would be the pressure head, which is 30, the kinetic head, which is 0.204, and the datum head, which is 5. So the total head is over here. Yeah, it is as simple as this, my dear people.